Okay, so I might as well start. So, as that part of the slide says, my name is Steve. As that part of the slide says, I'm a bit of a geek. Ignore the bit where it says consultant. I know it's the C word, we don't like mentioning that. I'm still a hands-on developer, despite that, which means this slide will contain code. So, can we actually write a version of Skype that works in a web browser, and can we do it in an afternoon? Yes. Thank you all, good night. I suppose you actually want to see how as well. So, over the course of the next 49.5 minutes, I'll go through the technology which you actually need to use to make this magic happen, how it actually works, that's the client flow, what the browser does, what the server bits do, the server itself, what you've actually got to build outside of what's provided for free in the web browser, and then the other stuff that's hiding around as well. So, the TLDR version, it's WebRTC. RTC, real-time communication. It is actually quite old. Not kidding when I say 2011. It was first created by Google in 2011, open to the community, given around, said off you go, use this. But despite the fact it's over 5 years old, it's 5.5 years old now, it still seems to be a relatively unknown technology. It is in most browsers, so it is available now, but it's quite hidden. It's amusing. Important part for us really, it's both the protocols which are used to make this stuff happen, and it's the API itself. So sometimes when you say WebRTC, you mean the protocols. Sometimes you say WebRTC, you mean the API. No one's ever managed to or decided to change that to make it a little easier, so hopefully context will work. It's built into the browsers and company supports it. That's what it is. It's something inbuilt into the browsers that just let you do voice communication peer-to-peer or video communication peer-to-peer without you having to write all the mucky stuff about video codecs, transmission data, retrying data that fails, all that stuff, all handled for you. This is what's supported right now, as of last week when I created this one. Everyone supports WebRTC because it's brilliant. Even Microsoft actually have it sort of roughly working, except for Apple. Apple really hate it because if you use WebRTC and you can have a voice call in the browser without plugins, no one's going to use FaceTime. So Apple have made a real stomp to say we're not going to support this. However, earlier this year, they did say we have now started to code it. So at some point it will eventually happen. They're starting to catch up. But for now, if you need to support people on Safari, you can't. What is WebRTC not? Well, it's not native. It is built within the browser, so there's nothing to download, no security things about saying, are you sure you want to download this executable, this DMG? It's already sat there. It isn't a plugin. Again, it is literally into the browser, so none of this extra rubbish to install there. And it isn't a licensing minefield, because Google open sourced it. Unfortunately, it's never quite that simple, because although the code is open source, some of the codecs that can be used have patents, and that's not covered under an open source license, so there are still some complications. But in theory, you can just take it and use it, and you don't have to worry about paying for anything. So this is the principles of how it works. We say it's a peer-to-peer protocol. Not quite true, but we'll see what that means in a moment. You've got user A in a web browser and user B in a web browser. They want to have a call, and for the purposes of this, I'll use call to mean either a video call or an audio call. User A talks to your web app and it says, hi, I'm user A. I would like to have a call with user B, please. User B logs on to your same web app and says, hi, I'm user B. The server then says, oh right, user A is over here. They want to call with user B over here. I'll put the two together. And they exchange some information to say where they are, what they're doing, what the particular, session description, STP, session description protocol, I think, says, right, this is who I am, this is what I'm doing. Oh, right, this is who I am, what I'm doing. That information is passed between them using your web app, and when they get that information, they go, right, we can now have a call. And then the media part goes between the two. So the peer-to-peer element of WebRTC is only for the media. You still need a server to talk the initial part of that protocol. If you read the advertising bump on WebRTC, it says it's peer-to-peer, you don't need a server. Line number one. It is not really peer-to-peer, only the media is peer-to-peer, and you do need a server. The flow is really quite simple. They've made it simple so JavaScript programmers can manage it. And it starts, I should have said that was being recorded. Access the local media, that's the first thing you've got to do. Obviously, that's get user media. That's not a WebRTC specific thing, that's an HTML5 thing. That's been in the browser since for yonks. You just say, I would like access to the user's microphone and or camera. And it says, certainly, here's a handle, here's a stream, go ahead and use this. You prepare WebRTC. WebRTC's primary object is called a peer connection. And this peer connection is set up on both sides. And each side says, right, I've got a peer connection. What do I do with this? Like, well, here's the stream, audio or video that I want you to send. I have a peer connection, I receive that stream. The browsers then have a little chat amongst themselves saying, well, what is it I'm going to be sending? Is it voice? Is it video? Is it any combination of the two? They then agree on how they'll communicate that information. So it might be a case of the browser say, well, actually, we're on the same local network, so let's use the local network to send this traffic so it's quicker. Or it might be that says, actually, we're on the local network, but there's a firewall in the way, so let's go outside the firewall and back again. That is how they'll actually communicate. And then once all this stuff was agreed, it just works, just like magic. It's simple-ish. So let's break this down into little blocks of code. The first step is the get user media. You'll notice the first thing here, it's WebKit get user media. Because when it was first developed, no one was quite sure if the API was going to work, so they prefixed it with their WebKit. And Microsoft have their version, which is .ms, get user media, and so on for each of the other browsers. There is a thing called adapt.js, which abstracts all this away, so you just call get user media and then it works. But I'm putting these things in slides just to remind you that if you do it properly, there will always be little gotchas like this. The same is true on any methods, by the way, in WebRTC. We say it's a peer connection. It's actually a WebKit peer connection. There's also an MS peer connection for every other browser as well. So you say, hey, I'd like some user media, please. I'd like to have the access to the video and I'd like access to the audio. There's a lot more that can go in those two parameters there. Those are termed constraints, and that says, I would like the media and I would like it like this, please. You could expand that to say, I would like a video and I would like the front video. Now what that means, if you've got a camera such as this, there's a camera on the front and there's a camera on the back. WebRTC will actually distinguish between the two of them, so you can say, I would like a camera, but only give me the camera that's facing this way. Or I want the camera, but I only want it's facing that way. Or you can say, I would like video, but only if it's 1024 by 768 or greater. Why would you want that? Well, in one example, which is actually a real example that has been deployed into the world, an insurance company or two now have actually bought into this technology, so that if you've had an accident, you can hold your camera phone up and you'll show them the damage to the car, and they make an assessment there and then based on the damage. Now, if that was a smaller resolution, they couldn't actually tell enough information. So the app will say, no, it must be a really big image to actually get the detail that's necessary for my purposes. You can also say, I would like the video, but only if it's small, because I'm on a really bad device, I've got pretty awful broadband here, it better be small. And you can restrict it on that. The same is true of the audio. You can say, I want audio, but only if it's high quality, or only if it's low quality. And there's a lot of other bits of rubbish that go in here. And also, because we say WebKit get user media, or MS get user media, it also means the parameters and the format of those change slightly between the WebKit ones and the MS ones. And yeah. But don't worry about that, you can do it in an afternoon. I'm pretty sure we're still on target to get it done in an afternoon at this point. So, the next thing is prepare WebRTC itself. That's the peer connection thing. So again, WebKit, WebRTC, peer connection. This is mostly boilerplate stuff. Unfortunately, the constraints vary depending on the platform that you're on, but otherwise it's all just there. And of course, you can give it some stun and turn servers, which of course we haven't mentioned, and is not something the average JavaScript monkey is going to be able to do, because it is a server stuff. Two things, the turn server and the stun server, just briefly. When you, I know this is all basic stuff, I'm just, I know probably half the people here know it anyway. So, when your bog standard desktop connects out into the real world of the internet, it will go generally through a router, and it'll be behind this sort of natting thing. So your IP will be 192.168 something, but to the rest of the world, it's maybe 55.12. something. Well, because you've got your local IP and no one can actually talk to that local IP except you have to use that sort of public-facing IP. Unfortunately, you inside the network don't know what it is, so you talk to your stun server outside and says, by the way, what is my real IP? And that tells you, and then you can pass that to the other person that wants to call you. That is what that server is for. And the turn server is useful for when you're both behind a firewall or one of you's behind a firewall and it says, right, well, I can't send the media peer-to-peer, I've got to send it out of the network and back in again. And the turn server is able to do that. The turn server takes all that media and throws it back again. At this point, you've got to go away, you've got to set up that stun server, you've got to set up that turn server. Google do provide a stun server because it's very cheap to do so. It's, it takes almost no CPU. Turn servers, on the other hand, they're generally not public, they're generally paid for things because the amount of cost in shoving that media up and down all the time is actually a noticeable cost. So you can set those things up and they can take some time, but otherwise it's not too difficult. General boilerplate stuff. You add the media stream onto the peer connection. You've already got that. When you do get used media, there's a callback. It says, right, here is the stream that I have now received by opening the camera or the microphone. You add that to the peer connection, and you can add as many streams as you like or your machine can handle. So as we're saying, you've got two cameras, one that looks at you, one that looks away. You could actually add both streams if you wanted. You could add multiple microphones, put those both in there. We've now got the media streams happening, so what is it they're communicating? Well, just because you get the video stream and the audio stream, you don't need to send both if you don't want to, and the other person doesn't have to accept them if they don't want to. If they're on a fairly slow connection, they might say, no, I don't want video. I'm not happy to accept video. So there is that transactional element of saying, I want to give you this, I don't want to receive that. And this is where you set it up. And the way that it's set up is with an offer-answer situation. So caller A will say, I offer you my video camera, I offer you my microphone, and the person at the other goes, I accept that microphone, or I don't accept that. And because all of this is happening in JavaScript on each of the clients, it means you as a JavaScript programmer have the chance of rejecting or changing things as things go along. I will show you, and that's the other side. You'll notice it's almost identical, so the person that does the offer and creating an answer is almost exactly the same. That's intentional. I will break out of this for a moment because without the network I can't show you everything. But this is obviously you can't go to localhost, but if you just go to the WebRTC side, there's a URL at the end of the slides. This sort of just shows you what it does. So there we go, that's the normal. Creating the peer connection. The code that you see on the slide is exactly the same code that is running here on the example. You add it in, you create the offer. So that is the offer. And I will now spend the next 2.5 hours explaining this. I hope you've got enough caffeine. The reality is you don't really need to know any of this. The only bit you'll ever look at is type offer. The other one is type answer. This is the offer that person A gives to person B, and the answer is what person B gives back to A. This contains pretty much everything it needs to know about the media stream it wants to send, or media streams that it wants to send. As yet, it doesn't say how, so it doesn't say in here, I'm going to connect over the local network because I've realised we're both on that same network. It just says, this is what I want to do. It's all pretty much self-explanatory, I think. I don't think there's even anything there that's even remotely amusing, other than the fact that you've now got to find some way of getting this offer from browser A to browser B. You haven't set up a peer connection yet between the two machines. There's nothing flowing between the two. So at this stage, you will need the server to say, here's the offer. Server, please give this offer to client B. When client B gets that offer, it then has to create an answer and then ask the server to give it back to client A. At this point, they know about each other and they can then start to talk. The next stage is once you've got the offer, you'll send it and so forth. But you'll notice there are two steps here. First, that doesn't really show up, but no. The first step is you receive the offer, and then you set that offer into the system. This is two steps. The system has received the STP, It knows it has to apply that to its peer connection, but it doesn't do it. It asks you, as the programmer, to do it for it. Now, this is not pure and utter laziness on the part of the WebRTC programmers. This is for one very, very useful thing. That you've been given this offer. The answer is almost exactly the same. It's a pile of gobbledygook. But instead of applying that directly, it gives you, the programmer, the chance to change it. And I think it's also fairly straightforward exactly how you would change this and why. But it's there. It's available if you do want to. And that's why you'll find that in a lot of cases, you're thinking, why have I got to do these extra little steps? That's why. So let's flip back and continue. So, browser A creates an offer, says, I'm offering you the chance of video, audio, whatever else. Client B says, I accept that, I want audio, I want video. They now know what they're going to communicate. You then have to work out how. And this is where ICE candidates come in. How they communicate. How is machine A actually going to talk to machine B? As we said, they could be on the same local network. And if they are, there'll be a candidate that says, I've got this IP address, I've got these ports open, just try it. Have a talk. If you're on a local network that starts 192.168, there's a reasonable chance we're on the same network. If you're behind a NATing, which often you will be, then you'll get another candidate that says, yeah, I'm behind a NAT, it looks like this. And if you've got additional servers in the process, a turn server, for example, it will say, yeah, I know about a turn server. It's over there. It looks like this. And you can generate, or rather the machine will automatically generate for you sometimes 10 or 20 ICE candidates, all different ways of the two clients being able to talk to one another. This is also where one of the security issues in WebRTC comes in, because this is JavaScript, it's run on the user's machine, and you don't need permission. You need permission to access the webcam or access the microphone. You don't need permission to gather ICE candidates. So you could just run a little piece of JavaScript on your web page that gathers this information and sends it back to a server and says, by the way, did you know their internal network is a 192.168 internal network? Did you know they're going through a NAT that looks a bit like this, and this is how they would get through that NAT? There is maybe a potential security thing there. Most people don't really care because it's already hidden behind the NAT, so you can't access or do anything dodgy. But if you want to try doing something dodgy, this is how you start doing it. There was an Italian hacker group called Hacker Team, or Hacked Team. One of their exploits was basically doing exactly this thing. They would use this, and WebRTC to sort of probe out on the internal network to find out how their networks was built inside a company. Because you don't need to explicitly give that web page permission to do this. So we've got that. We've got the ICE candidates which are generated automatically by the system for you. And again, you as the programmer set those ICE candidates into the WebRTC peer connection. Again, it could do it for you automatically, it doesn't. It gives you the chance as the programmer to take the ICE candidates and fiddle with them if you want to. There's not many reasons why you would, but it gives you that option. And then once you've told each machine about its ICE candidates, the machine A will say, yeah, these are the ways that I can connect through to the network, and machine B will say, yeah, I can connect these ways. And once both machines have been told about the others, the code inside that goes, right, well, you can do this and I can do that. You can do this, I can do that. You can do this and I can do that. Right, this is how we'll do it. And they both independently work through their list of ICE candidates and the other machine's ICE candidates, see where they match, and then the data just starts to flow. Very simple. Another interesting security bit, by the way. I'll come over here. Mid-lecture activity. I'll come this side. This actually also breaks firewalls. Firewalls have the general idea that if I've sent data out, if data comes back to me, then it's probably right, because I probably asked for it and it's probably legit. Well, if your machine just sends, your WebRTC browser just sends out a load of data saying, I'm trying to reach a machine, I'm trying to reach a machine, there's enough data going out that if you then push stuff back through those same ports, it probably gets through. And this is what this port information is stored here. Because both of these machines trying to communicate know what other ports they're trying to talk out on, they can actually talk in through the firewall to the other machine. There was probably a dodgy purpose for this information, but I have no idea what it is, because honest gov, I'm a nice boy. Back to the prearranged slides. So you create the ICE candidate, or rather you request that the browser creates the ICE candidates for you, it trundles away, callback happens, it then feeds you 5, 6, 20 different ICE candidates, different ways you could potentially get out of your network and into the big wide world. And then once all that happens, obviously the media streams flow either between the two of them, because they've seen it's a local network, through the stun server, because they've seen the return server, because that's the only way they can get out, or by using the sort of more public IP just beyond the NAT. So we've said it needs a server. Unfortunately, that is true. That's, it's not in the brochure. WebRTC always said, oh, you don't need servers for this. Yeah, you still need the servers for that signaling part that in the first instance says, I am browser A, where on earth is browser B? So you've got to code that. You also need to code the user stuff. You could have a free service. There's no reason why you couldn't make it free. But at some point, you're going to want to start locking it down and having user accounts. None of that is provided by WebRTC. WebRTC doesn't even supply you template server code. You have to write everything yourself. This was also intentional from the WebRTC team. They said, if we create a standard for signaling, which mandated exactly how browser A would talk to browser B, and the exact methods they would do that signaling, it would A, hold up the standard for another 5 years, and let's face it, standards are really quick to implement, so holding up another 5 years, no one's going to notice. But they decided we don't want to delay it any further. Also, if they mandate how it has to happen, it means there's no room for innovation. So they took what may well be the better route, although it's certainly the easier route for them, and provide no clues on how signaling needs to work. As a consequence, it does mean that if you want to connect your WebRTC voice app to a SIP phone, for example, it becomes much easier because you are controlling the signaling part of it. So it's up to you how you deal with that part. And people are connecting WebRTC app to SIP phones and to real-life phones. There's quite a few companies out there that will gladly take your money or your user account details to provide you with solutions. People like Twilio and that. They will connect WebRTC through to the real world of proper phones. So this is the real, this is what it's really like. We've pointed out the problems with firewalls and that. This is what really happens. Most of the time the peer realizes it's stuck, talks to the cloud, has to go over the firewalls, and then use a separate stun and turn servers to get the media. I know the slide earlier says media goes directly from that peer to that peer, and from that peer directly back. It generally doesn't. But it doesn't matter because these are still relatively easy to build. There's open source versions of all this stuff. It's a case of joining it, plugging it together. It does give you a few advantages if you end up having to go through a server. If you want to do recording, you generally can't do it if it's peer-to-peer. You have to rely on one or both of the peers recording their part of the conversation, or both parts of the conversation, and then uploading it to whatever service you want. But of course that relies on the peer doing it, and doing it properly. It could break. You could have code, or the machine would fall over before the call had ended, and you wouldn't be able to get that information out. What else is not provided on the server is any of the infrastructure. So we mentioned user discovery, the idea that you'll log on with your username, so browser A knows where browser B is, and so forth. Any of the signaling stuff is not provided, so you have to do that. Any pub sub thing like Pusher or whatever, you can use those and it just works fine. That's what I use. I've built this sort of platform 3 times now, and it just works. You just stick a pub sub in the middle, and you send the information, and it's just there. There's no trick to it really. The turn servers is what will send the media over the firewalls to the other machine. If you want to do any recording, again, you probably will want to put that on the server. You can do it locally in the browser. The browser's actually got enough stuff in it that you can record audio and video within the browser as a blob, which can then be uploaded, saved, or munched in some way. And get user media as well. Because it's an HTML5 thing, you can actually screw with that image if you like, but it won't be the image that's generally sent. So if you want to, if it's got something, if you've got a microphone, for example, that's a bit quiet, you can boost the microphone signal, but it only affects the local version, not the stream that's being sent. But if you put a server in the way, you can. So you could have a server that will do the boosting of the microphone, turns the voice into a Dalek, puts a filter over the image, put silly hats and glasses on to, you know, if you're doing facial monitoring, you can work out where the eyes are, you can put glasses on, all those sort of things they do in those little app things. Mobile is sort of supported. A number of mobile browsers do have working WebRTC components in them, except obviously Apple's, but it's there and it kind of works. Again, if you are on the mobile device, you probably will put constraints in there to say, yes, but don't use all my processing power for the voice, let only do like an 11 kilohertz codecs, just so it doesn't completely destroy the connection. And there's no testing, obviously. Does anyone actually do tests? Or are people lying? There is nothing there to actually prove that this sort of stuff works. You know, there are bits of tests here and there, but you will have to write your own test to make sure things work. And it's not actually that easy. Every time you do a voice call with WebRTC, you'll say, I want a call, I received the call. This is something that requires a human. On the very first time you access WebRTC on a new web page, the little box pops up. Do you allow the camera? Do you want to allow the camera to be used on this web page forever and ever and ever? That requires a human clicking something. So if you're going to automate these tests, you have to make sure that your browser has already got those exceptions built into it. So it's not necessarily straightforward. And if you are doing a call, you will want something to actually start talking into the microphone. That's not an automated test now. This is requiring a human to actually go through the steps manually. And obviously, business logic will never be included in WebRTC. It's, you know, examples of business case come through all the time. The conference I was at a couple of years ago on this, basically everyone had exactly the same business case, which was a company that sells sofas, as an example, would have all their sofas on the web page. You would click a WebRTC call button, that would call one of their operatives, who would then talk to you about the sofa that you just clicked on. Now, because it's all in the web, it knows what sofa you're looking at. So the agent at the other side knows, oh right, they're looking at the brown version of this sofa. They already can see that they've got so many in stock, that it's this good, or it's going to be on special offer. Also knows, through various things like tracking cookies, that you've been to that site 4 times already. It knows you've looked at 2 other sofas, but you've come back to this one multiple times. This can give the agent a bigger clue as to, right, I need to sell and close the deal by doing this, because this person's been multiple times. You know, this is a fairly common use case now. Another interesting use case that's actually come up, this was actually a hackathon thing that was done many years ago, was that it was for an emergency services thing. And emergency phone calls have a completely different set of sort of requirements to fulfill SLAs, because it's emergency, this is important stuff. And one of the hacks was basically, you call the emergency services, they say, you know, you say there's an accident on the high street or whatever, car crash, someone's injured. They say thanks very much, people are on the way. They then send you a text link, a link to a web page via text message. You then click on that, browser opens to a WebRTC app where you can actually hold your phone up to the accident to say, look, this is the person, they're bleeding from here, how serious is this? And then the person on the other side can then say, right, you need to press it like this, and they can give you first aid help to, you know, while they're waiting for the ambulance to arrive. What this also does is it accesses, because it's now in the web browser, you're getting your GPS coordinates of where you actually are right now if you do end up moving. So they can give guidance to the ambulance to say, right, they are actually here, this is the way you need to get there. And other things can then be sent out and say, right, well, don't take this route, take that route, because that route's congested, so the ambulance can get there quicker. And it was a very nice hack, it's a good proof of concept. They keep, I think it's the guys from IP Cortex that did it. Their office is actually inside Bletchley Park. So if you ever get an excuse to go and see them, just go for that reason alone. And they invented this just as a hack thing, but there's no reason why this can't be implemented in the real world to be used to help, you know, do important things. Not the sort of stuff that we do here, which is basically chat roulette. So, oh, some people remember chat roulette, that's good. I thought I was the only one. So no business logic. So if you're doing a call center, you can build call centers with this stuff. And there were quite a few people who have built a call center application on top of WebRTC and sold it for money to real people. None of that business logic's in there. A call comes in, it's going to go to 1 of 10 operators, you've got to build that. You've got to build the stuff that says, I'm an operator, I'm free, I'm an operator, I'm still on this call. If you're doing billing, as an example, there's a variation of Hangouts where, I think it's called Helpouts, where you as a guitar teacher, for example, can use the Hangout technology to teach guitar, and if you're on there for 15 minutes, you will be billed for 15 minutes of guitar tutor time. None of that's supplied, obviously. You're going to have to go away and build that. No scaling is involved, so if you do have to have a turn server to direct all that media traffic around firewalls, you're going to have to manage that yourself. You're going to have to manage the firing up of however many machines are necessary for whatever your users happen to be on at that time. And fault detection, yeah, if it returns an error, forget it. You know, if I'm trying to talk, you know, on a phone it's fairly simple. You can hear that it's breaking out, or you know you're in a room that's pretty much a Faraday cage. But if you're dealing with WebRTC, as you are with most web techs, you've got no idea. Browser A is not talking to browser B. Right. Is it between browser A and their NAT? Between that NAT and the ISP? ISP backbone? ISP the other end? Or other local network? There's nothing in WebRTC and nothing general in the web browser that gives you that sort of a breakdown. You're going to have to start installing native tools at this point to try and analyze what's going on the network, whose fault is it, and so on. None of that stuff is available. So I thought it's all very good talking about this, and as I say, I've done this a few times now for various companies. Let me just do it, just to see, can it be done in an afternoon? How much effort is it to actually build Skype in the web browser? So the first thing I needed to do was the JavaScript. That's simple enough. WebRTC has got so many APIs that do most of the magic for you. Turns out there's 1,809 lines of JavaScript in the little example I hacked up. That's not a lot, but that's still more than zero, which is what the advertisers tell you it's going to take. And this excludes, as it says, it excludes all the shims and polyfills. So when I pointed out that it's navigator.webkit get user media, and there's 5 or 6 versions of them, it doesn't include the code that abstracts all that away. It doesn't include the code that does each different version of peer connection. None of that's included in those 1,809 lines of code. Next up, is this the one I think it's going to be? Yes, 1,522 lines of PHP. I figured since it's a Perl conference, if I can't alienate half the audience with JavaScript and the other half with PHP, I'm not trolling hard enough. So I thought, let's try coding this in PHP. This will be a laugh. Yeah, laugh is the operative word, I think. It's only 1,500 lines. That's not too bad. That's most of the server side, where it says, I'm user A, I want to talk to user B. Transmission stuff, holding some information just to say, I'm in room A, for example, as an example. That's all information. 1,500 lines. Doesn't include the object relational stuff, but, 1,500 lines, that's doable as well. That's not too difficult. You can code that. 437 lines of custom JavaScript. Well, what's this custom JavaScript stuff that isn't the normal JavaScript? Well, this is things like, which microphone would you like to use? One of the first things you'll generally do is you'll say, well, tell me about every microphone, camera, and add-on that you've got in your system. And it will return you a list. And there'll be a human-friendly name and a computer-friendly ID string. You want to get that. You want to put them into a nice little list. You want to select those. You want to then open that correct stream. You want to attach that stream to the peer connection. Those custom little pieces on there, 400 odd lines of code for one call between 2 people. This is not, there are 5 people in this room, this virtual room, all having a chat. No, this is for one call between 2 people. No clever stuff. And because it gets more difficult. If you and I have a conversation over WebRTC, for example, I send you a stream, you send me a stream. 2 streams, easy enough. You want to join in. So that's 1 stream, 2 stream, 3 stream, 4 stream, 5 stream, 6 stream. Peer-to-peer. Between every 2 peers in that network, there has to be 2 streams. One this way, one the other way. You want to now join in. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And at this point, you really start flooding your bandwidth with media streams that you really can't cope with. That's a lot of data going backwards and forth. And this is the general way that WebRTC works. If you want to have a better technology, then you have to start building more things. There are technologies you can build, or sort of half buy, half open source, where a big server in the middle will take all the streams in, it will build those video and audio streams into one audio and video stream, and then send it out to everyone else. So in essence, each user is only still dealing with two media streams, one from them to the server and one from the server to them. But the server now has to be twice as complicated as it used to be because it's doing multiple codec video compositing and audio compositing. Now in some cases that code would be quite simple. In this sort of environment, for example, I'm doing most of the talking, you're doing most of the listening. So you could actually say, well, we don't need that stream. We could just have one stream from Steve to everyone else, and maybe on question and answers you'll have one stream coming back. But again, you then have to start building that into your app to say, right, during the first part, you switch off all these streams, you switch off all of this, then at this point you switch these ones on and you add those streams, now you remove those streams, and it just gets exponentially more difficult. And it's only 1,800 lines of code, 2,000 lines of code, 3,500 lines of code, if everything works. The reason I like the phrase technology consultant and geek and CTO and all those other nice things is someone else has to write the error handling code. There is no error handling code in any of this. If it fails, it puts up an alert box. Doesn't give you any helpful things other than it doesn't work. That's it. That's all I bother putting in. So if you want to do it properly, where you're going to help the user and say, I couldn't access the microphone, are you sure it's turned on? Have you got it? All that kind of extra stuff. Trying to be intelligent, saying, well, I failed on this API call, but I succeeded on this API call. Trying to intelligently work out what's gone wrong to help the user. Nothing like that in there. That's still more work. WebRTC isn't just really about audio and video, although that's its intended domain. You can get connection stats. So this is an example, for example. Never mind. This is water, not vodka, I assume. So this is from Chrome, and this will show you lots of nice things about what's going on those streams. How much bandwidth is being used by the audio, how your packets jitter, which is probably not on there, giving you an indication on the quality of that link. If you're getting a lot of jitter, you can pick up that information and go, I'm detecting a lot of fallout on your network. Are you sure you're happy? Do you want to try and downgrade? That sort of thing. And although this is a visual thing inside Chrome, you can actually make a call to get stats, and you'll get a nice block of JSON giving you all this information, so you can programmatically work through it to try and work out, is there a big enough problem? What's the quality of this call? And you can take this information, send it back to your server for that, so it can be processed later on. And because it's a piece of JavaScript, it can run on the user's machine, and the user never knows you're doing it. I did this, not this exact thing, but in one of my previous things, I did education. And what we did is we were rolling out this technology to the schools, and we wanted to know, well, what schools are more likely to work with WebRTC? Which ones have got stupid firewalls in the way? Which ones have got odd little bits of router that really munch the data packets? So we hid things like this on our homepage. And we tracked who was using it, how they were logging in, what users they were, and what sort of data we got back. And those that gave us good data that we like the look of, the nice candidates and all things like that, we sent them all back to the server, no one knew we were doing it, and we used that to target the schools that we thought they will work with WebRTC. What else have we got? Oh yeah, and the RTC data channel. If you're not just wanting to sell audio video, you can send real-time data between two peers using the WebRTC stuff. The API pretty much mimics exactly what you get in WebSockets. If your browser supports WebRTC, it already supports WebSockets because the two technologies are based upon each other, really. So you can send any data, strings, blobs, arrays, it doesn't matter. It's all data at the end. The nice bit you get about this is the fact that you can do anything. So as soon as you created the data channel, you can create virtual channels within that, and you don't have to do any more work. So if you're doing a game, for example, you can have one data channel for the player positions, another data channel which is for pick up items when things have happened in the game. You can have another data channel for updating high scores or what's going on in the rest of the game. Reliable or unreliable, as it says at the top. Those of you that were in Leon's talk earlier, you saw the little diagrams of saying how long it takes to get data between the two, because you've got offer, acknowledge, so forth. You can also create unreliable data channels that will send but not worry about getting a packet back to say, yeah, it's okay, I've got that, you can send me another now. This will just send the data out and forget about it. Why is that useful? Well, as you saw from Leon's talk, it's very useful because you don't want all that traffic some of the time. And if you're waiting for that extra reply, that is extra time that you could be doing something useful. And in games particularly, if you're moving through a world, it doesn't matter if the person misses an XY coordinate, because they're going to get another one in a tenth of a second anyway. So you don't need to clog up your machine and the internet data channels with all this extra rubbish, like, yeah, tell me when you've got that XY coordinate and I'll send you another one. There'll be another one coming along in 30 seconds. And you can do some actually reasonably smooth stuff in games with these data channels. So, the conclusions, he says, reading off the slide. I try not to read off slides, but every now and again I just get drawn into it. So it provides the API and the protocols. WebRTC is the API, it is the protocols. And it's there. It has lowered the barrier to entry. Writing audio and video codecs is quite hard. I did do it once, and I thought, no, this is not a way to make a living. This is just painful. All that stuff, it's all done for you. Handling jitter, that's all handled for you. If the machine notices you're getting a bit more jitter, it will downgrade the quality of the audio automatically for you, so it improves. Because having a lower grade audio is better than having choppy audio. You do need to provide the signaling still, so you will need to have a server, and you will need that server to do your user discovery and connect those two peers up in the beginning. So there is still some work to be done there. And as we found, like the data channel, not a lot of people are using it because you think, wow, I can do a video call in the browser and it's just so easy. Things like the get stats to tell you how good that call is, to tell you what IP you're using on your local internal network, sending data of varying descriptions between machines in real time. All very useful stuff. There's a guy called Tim Panton who now works at a company called Pipe doing webcam IoT things. I know everyone does something with IoT these days. What he's done is he has sent a video signal from a webcam on a Raspberry Pi to another machine, but he's not using video. He's taking the image from the webcam as an MJPEG and squirting it down the data channel. It's an interesting approach. You can do odd, weird things like this just because it's there. So there are lots of little interesting bits like that hiding around that you may have use for, the finding out IPs or whatever. Which does bring us mercifully to the end. I hope that's not readable at all, that link, but you can probably guess what it is. No. Okay, well, it's the Mark Ristige WebRTC guide. And that is... Yeah, it's that URL, which is basically that page where you can set, you can set up two machines on here, and as long as you're on a localish network, or you've got a way of copy and pasting that session description between the two machines, you can actually have a WebRTC call between any two browsers. Without the signaling bit, obviously you're going to have to send that through Skype, which kind of defeats the object. But it does mean you can at least try this without having to set anything up. And because the code, I think the code is reasonably decent, it's reasonably readable. It's on the GitHub link. So you can just go through each of the steps, creating the peer connection, creating answer, sending answer, to really get a feel for how it works. An amusing bit here, by the way, you must use HTTPS with this version of Chrome or downgrade to 46. One of the many issues which do exist, and WebRTC has a very low barrier to entry, but it still has a reasonably high barrier to exit. Because you still have to do a load of, that's the tweetable bit, I think. That's the tweetable buzzword. You still have to do a load of extra stuff. If you control who your users are, then it becomes reasonably easy. If you don't have control of your users, and it could be anyone on any browser to anyone on the other browser, you've got to handle all those odd, weird cases. So last Christmas, roughly, I think it was just after Christmas, Google decided that as of version 47, it would be mandatory to use HTTPS if you wanted to call get user media. Get user media, obviously, being the bit that gets the video stream or the audio stream. Well, at this point, you then had to make sure you'd got your certificates for any of those machines that were running. And even if it's a little personal pet project, you still need it. But not everyone will have version 47 or later, so some of them will be able to use version 46 and use HTTP, and those over need HTTPS, and you've got to make sure that you haven't screwed up anything there. And you've also got to know that they introduced it in version 47. And as all good software developers know, programs never go wrong. A new version is always better than the last one, and it never regresses at all. So you will find that every now and again, Google will release some new feature, or Firefox will put a new feature in, and then it will all just suddenly break, and you won't know why. But hey ho, that's why we make a living. So that's what I've got no idea what my time is. I'm probably coming very close to the end, but I may have time for questions if anyone has them. Yes, question.
About transferring this token between the two WebRTC participants. Would stuffing this token into a QR code work basically, so I can take a picture with my phone of that other phone and have or build a connection then?
In theory, that is definitely possible. Tim's webcam thing uses QR code to pair up two devices. The problem with using a QR code is the amount of data you can get into it versus the amount of data that's in that blob generally are not compatible. So you end up finding, well, the easier way to do it is to upload that to a server, then use the URL of that SDP packet to be the QR code. But theoretically you could, or you could have several. But
I did also notice that string will compress really rapid.
You pointed out a bunch of problems with things like NAT at the beginning of the way. To what extent do all of the WebRTC things handle IPv6? Presumably that makes a lot of the NAT problems at least go away.
Yep, as far as I know, the later browsers will support IPv6, so that the data blocks that you get, actually it's probably not those ones, see if I can.
The SDP ones?
Yes, the SDP ones. Did I have an example on this one or not?
Yeah, no, I suppose the summary of my question is, does SDP support v6?
Yeah, it supports a whole load of stuff that you'll never usually use, but you can. But you then have to know that this machine might be using IPv6 and then deal with that accordingly. Yeah, the formats, although they look junk, and they are junk to be fair, they have been created in such a way that you can add a lot more things to them than what are currently there. There are a couple of projects that make that easier to read and converts that into sort of a nice JSON format. Microsoft have got a completely different approach to that, which is ORTC, which is Object RTC. Again, to try and make that easier for you to go in and manipulate stuff and look to see what it's doing. It's useful if you know enough about how it works internally. So you could say this person's having a problem. What SDP did that user get? And you say, oh wait, they were on IPv6, but the other person was IPv4. That might be an issue, but it takes some digging. Yes, at the back was that question, or question on that side? Yes.
How much documentation or examples are around for building the server?
Not a lot.
Yeah, that's what I feared.
Yeah, partly that's because there isn't much you could do. Because it's all about, the first part of the server's job is to send that SDP packet from browser A to browser B and the answer from browser B back to browser A. Well, anything that can send a piece of data between two machines works.
Yeah.
Pusher as an example, you can set that up in 5 minutes and it's there. The rest of the work needed for the server are things like user discovery. You log on with your user, we attach this SDP to that user so it can be passed to me. That is pretty much going to be different for every use case that you have. Or it needs to integrate to your existing platform. So if you have, for example, a case of a school tutor and a school kid, and they're having a lesson via WebRTC, you're going to have to put that into the rest of your platform that also has the lessons that kid has done previously, the slides. So trying to provide examples of that server code become really quite complex, because there's no small thing you can just say, right, this is how you start. Because it is just sending data between two different users.
Okay, thank you.
Any more? Then I shall call this meeting. No? Yes? No? Okay. Then we end. Thank you.